We present Haptic UI, a gamified haptic UI for increasing trust in autonomous vehicles through the use of haptics. This project is part of the Student Innovation Challenge Mobility of the IEEE World Haptics Conference, which will take place in Japan in July 2019.
The objective of our work is to tackle the two main reasons that cause drivers to not fully trust Level 3 and Level 4 autonomous vehicles. The first one being the takeover request, an event which occurs in extreme situations in which the driver has to retake control of the vehicle. In the process of this action, it is highly likely that an accident takes place. Secondly, we wanted to find a way to make the algorithms that power self-driving cars work better, while at the same time help drivers trust autonomous vehicles by making them part of this process. Our ultimate goal is to engage these issues using haptics in a way that drivers will trust autonomous driving.
The equipment we used for this project was the HTC Vive VR headset for simulating the environment inside of a moving automated vehicle, a custom haptic glove. The glove consists of a simple glove equipped with an Arduino Nano microcontroller, a force sensor located at the tip of the thumb, and a vibrotactile actuator located at the tip of the index finger. On top of the glove, an HTC Vive tracker has been added in order for the glove to be tracked inside of the simulated environment. Finally, we used a touch development kit created by Ultra Haptics as a secondary control unit.
According to our design, the driver will wear the VR headset and a vibrotactile haptic device on one hand, while underneath the other hand, the touch development kit will be placed. The VR headset will render virtual bounding boxes around objects that the automated vehicle has been trained to avoid, like cars, trees, or people. The user will point to the bounding boxes with a hand that is equipped with the vibrotactile device and score points for confirming that the algorithm is detecting and classifying objects efficiently. Additionally, the user will score even more points by taking photographs of objects that the algorithm failed to detect as obstacles. The command for taking a photograph will be given via the touch development kit.
We will present two scenarios of a user interacting with our gamified haptic UI. In the first scenario, the driver is using a self-driving car and interacts with the bounding boxes of the surrounding vehicles. The haptic glove gives the user the ability to aim at the bounding boxes of these vehicles. When the user aims correctly at a bounding box, it changes color from green to red. The driver confirms that the bounding box has correctly identified the obstacle by pressing his thumb against his index finger. If the hit is successful, the bounding box disappears, and the actuator located at the end of the index finger gives a feedback to the user, which conveys a positive feeling. If the hit is a miss, the actuator again renders a haptic feedback, but this time by conveying a negative feeling.
In the second scenario, the driver again uses an automated vehicle and interacts with the UI. Suddenly, the driver notices that the passing car has not been detected by the algorithm of the automated vehicle. In this case, the user has to aim at this car and touch the surface of the 3D sphere inside of the environment. This way, the driver takes a picture of the incident. The sphere has underneath the touch development kit, which renders the haptic feedback of a button being pressed. Playing the game rewards the driver with points. The user scores 5 points for hitting a bounding box and 150 points for taking a picture of a car that the algorithm failed to recognize. Since this way each driver produces annotated data for the automobile industry, the car company will reward the driver for his service with perks like toll-free driving for a weekend.
We evaluated the usability of our system with a questionnaire. In this process, 9 subjects tested the system and were asked questions while interacting with our UI.
This project has a lot of potential for future research. First of all, testing should take place to figure out whether or not the takeover response time decreases by playing the game. This could be tested in a simulated environment where the driver has the ability to operate a virtual vehicle. There, the response times will be measured in 3 cases: while playing the game, while doing an irrelevant secondary task, and while doing nothing. Finally, since this project was initially meant for augmented reality technology, engineers should find a way to reliably render the view of the car cameras in augmented reality. This means that the driver will be able to see the bounding boxes of all the surrounding vehicles in his view and be able to interact with them.